All right, so this is 612 solving by factoring. So what we're gonna do is use our zero factor property. Your book may call it something a little different, but zero and factor shit is going to be in the title. And so what that means for us is that says that if A times B is equal to 0, then A is equal to 0, B is equal to 0, or both of them are equal to 0. So the key here is that one side has to be set equal to 0 in order for you to use the zero factor property. Also in there, you see that word factor. That means we're going to factor our expression as much as possible in order to apply the zero factor property. So directions could just be solve. Looking at y squared plus 7y plus 12 equal to 0. So if one side is already equal to 0, then you're good to go as far as trying to factor is concerned. So we'll go ahead and do this. Now factoring, once again, we've already covered. So if you have any issues or problems with factoring, make sure you get with me outside of this class. But this will factor to be y plus 3, y plus 4. Now, because of the zero factor property, we can set each piece or each factor equal to 0 and solve each one of them individually to get our solutions. So subtract 3 from both sides, y is equal to negative 3. Subtract 4 from both sides, y is equal to negative 4. And those are our two solutions. All right, let's do another one. And that's pretty much the foundation of this whole section. Here we have 3w squared minus 17w equal to 6. So we notice that one side is not equal to 0, and we want to make that one side equal to 0, so we'll subtract 6 from both sides. 6 is canceled on the right. So now we have 3w squared minus 17w minus 6 equal to 0. Go ahead and factor that out. And maybe negative 6. All right, let me see. Negative 18, positive 1, yep. So this will factor out to give us 3w plus 1, w minus 6. And go ahead and solve. Here we'll subtract 1 from both sides, so every 3w equal to negative 1. Divide by w, divide by 3. W is equal to negative 1/3. Here we'll add 6 to both sides. W equals 6. So once again, we have two solutions. And remember, your solutions are values that make your statement true. So if I were to plug in negative 1/3 into the equation, then that will equal to 0. Or if I plug in 6 into the equation, it will equal to 0. All right, here we have 15t squared plus 15t equal to 0. What we can do right here is factor out your GCF. That'll be 5t. What's left is t plus 3 equal to 0. Once you factor completely, follow the same procedure. Set each piece equal to 0. 5t equal to 0, divide by 5. That means t is equal to 0. For t plus 3, you subtract 3 from both sides. T is equal to -1. All right. Here we have 2y cubed plus 6y squared equal to 20y. Once again, we have the right side, or we don't have either side set equal to 0. Doesn't matter which side is set equal to 0. You just need at least one of your sides set equal to 0. And since we don't have that, we need to do so. Here we can subtract 20y from both sides. So that'll be 2y cubed plus 6y squared minus 20y equal to 0. We can factor out a GCF of 2y. That's going to be y squared plus 3y minus 10 equal to 0. And then that trinomial can be broken down into y plus 5y minus 2. All right. So now set each piece equal to 0. Divide by 2, y is equal to 0. Subtract 5, y is equal to -5. Add 2, y is equal to +2. This time we had 3 solutions. If you notice, our highest exponent was 3. Lets us know we should get those 3 solutions. Before, our highest exponent was 2. So that's why we had 2 solutions. All right, any questions? Any questions? All right, here we have x minus 2 times x minus 5 equal to -2. So what we need to do is expand this out because we have this -2 sitting over here. When we want to bring the -2 over, but it can't combine with anything because we have these parentheses over here. So we need to go ahead and do our distribution and then bring the -2 over by adding it to both sides. So x times x is x squared minus 5x minus 2x plus 10. And that's still equal to -2. Combine your like terms. And then add 2 to both sides. So this is what we have now. X squared minus 7x plus 12. All right, make sure you don't have any questions. If you have any questions, make sure you ask them. Once you have your trinomial set equal to 0, you go ahead and factor that out. Once you're done with your factorization, set each part equal to 0 and solve. All right, let's do it at least one more. All right, so here we have 8 times the quantity of x squared plus 2x equal to 7x squared minus 64. Go ahead and distribute. That'll be 8x squared plus 16x equal to 7x squared minus 64. And just like before, we need one side to be equal to 0. So we can subtract x squared from both sides and add 64. Once they cancel on the right, giving us 0. On the left, 8 squared minus 7 squared is x squared. And then the 16x and the 64 can't combine. So they just go into your trinomial. Make sure we are okay. All right, so now we can factor this. All right, so it'll just be x plus 8, x plus 8. And we'll get a repeated value or repeated solution of negative 8. All right, questions? Any questions? All right, so that's 612. 612 in a nutshell. I think we had said that we would do just 612 today. Complete the square and everything. Okay. So we'll just hold off and do 612 today. But I know Coley had questions on complex numbers.
Yes. It's complex fractions. You can bring up my record in
Mm-hmm.
Connect. I don't mind if the other students see it.
Mm-hmm.
Is I think I stopped at 19.
Mm-hmm.
They don't see my grade.
Say again.
As long as they don't see my grade.
So you talking about number 19 in the review?
Yes,
Okay, right, gotcha.
I think it's 19.
So you got 19 right,
So it must be
20.
20.
20 is where you, yeah.
I get confused on how to do method one and method two.
Say again?
I get confused on how to do method one and method two. I
Right,
know method one, you can just flip it, right?
right.
Method two, you use the LCD, right?
Yep.
If you bring up 20, I can talk through to what to do, but I get stuck.
Mm-hmm.
If you draw the problem up and I can,
So this is your 20.
all right. Now, method one, I got to flip it, right?
Well, see, method one, you can't do method one. This is why I always emphasize method two, because method two will work no matter what the situation is.
So if we use method two, my LCD would be 10x.
Yes.
Let me write this down.
Because see, if you were to do method one, the first thing you have to do is combine this and make this one whole fraction. Then
Okay.
combine this and make this one whole fraction as well.
See, I wouldn't know. I didn't know to do that.
Mm-hmm.
So I'm just gonna stick with method two. Cause I'm confused.
Okay, not a problem. And so method two is the first step, like you mentioned, is to find the LCD.
My LCD is 10x,
Mm-hmm.
and what I do is to break it down for myself to make it easy, well, more understandable. First fraction that's in the numerator, I put it in parentheses and I put the 10x on the outside.
All right, so you said the fraction in the numerator?
Yes, I multiply that by 10x.
Okay, now you need to multiply each term.
Each, oh, okay,
Mm-hmm.
that's 10
Yep.
times 10x minus 10x times 5.
And
And
so if you look at my step two, you notice what I said there was multiply each numerator by the LCD.
that's, but the 2x is going to divide into 10x, right?
Mm-hmm.
Right. I just want to make sure I'm cool. Now, when I go to the bottom, I take 10x times 5 minus 10x times negative 2.
Mm-hmm.
So I make the 10x negative.
Say again now?
The 10x is negative. 10x
Mm-hmm.
times 2 over 10x. Oh, the five is over 10x. Now, when I go back to the numerator,
Mm-hmm.
that's 100x.
Yep.
So rewrite it 100x minus negative 50x. Wait, hold on. I got to divide negative 10 by 2, right?
Mm-hmm.
So that's negative 5.
Yep. So this 2x cancels out with this 2x and leaves you with 5.
And negative 5 times 5 is 25.
Mm-hmm.
Then I draw my line. I do the other fraction. The 10x's cancel out. That leaves me with 5 minus 20x. Now, where I
Yep.
go from there?
Say that last part again.
Where do I go from there?
All right, so you want to see if it's possible to reduce it.
Now the 100 can be divided by the negative 20x, right?
All right, so you got to be careful. Now you can't lose your factoring techniques or your simplification techniques. So remember, one thing we said we want to do is if x is in front here, then bring it out front, bring it to the front, down bottom as well, so we can do a clean comparison of our expressions.
But I have to do a -1 then, right?
You'll see it.
So
So that'll be 100 minus 25 over 20x, negative 20x plus 5.
so rewrite it as a -20x plus 5.
Well, we haven't changed anything. You know, the 20x was negative and the 5 was positive. We just rearranged our terms so
So
that x
I
will
don't have
be,
to do that -1 process.
well, it's going to happen in a second. But
Okay,
we got to make sure we understand why it's happening.
that part I don't understand.
Right.
So you telling me just rewrite it?
Say that last part again.
You telling me to just rewrite 5 minus 20x? Just rewrite it.
Right. Just so that we can put the x term in front in both cases. And like I said, we can make a clean comparison to both expressions.
All right, and 100 divided by 5.
You said 100 divided by 5?
Yes.
Why you dividing it by 5?
You said I got to simplify it. Well, 100 divided by 25.
Well, remember, we simplify by factoring first.
Okay.
So we can factor out 5. You know, if we were to factor out 5 from that 100 and from that 25, that leaves you with 20x.
But the largest factor I can factor is 25.
No. Yes. I'm sorry, I was looking at something else. Yes, you could have pulled out 25. I was looking at my bottom.
I should write 25 on the outside.
Mm-hmm. So if you want to go 25, that's fine.
25 on the outside. That's 4. 4x minus 5
Mm-hmm.
over 5. And would that 5 be positive or negative?
What do you think? Because now remember, you're trying to cancel out as much as possible.
I'm just going to make it positive because I'm not sure.
Okay, well then pull out the positive, and then tell me what you're left with.
Positive 5, negative 4x
Mm-hmm.
plus 1.
You got it. All right. So now, what can you cancel out at this point?
Nothing.
Oh, not necessarily.
Well, I got a negative 4x and a 4x. They two different signs.
Well, the first thing we can recognize is that we have 5 divided by 25.
Wait, where did I mess up at on the top one?
Say that again.
I messed up on the top one then because what I got on the top is 25 4x minus 5. You put 1.
Well, yeah. Well, don't forget to pull 25 out of that second term.
You're right.
So if you pull 25 out of that second term, then that'll only leave you with 1.
You're right.
Mm-hmm. So you cool now, or?
I'm cool.
Okay, good. So
You can
would
see
that
I
be,
don't know what I'm doing.
say that last part again?
You can see I don't know what I'm doing.
Oh no, that's not the case. It's just that you missed the term. A lot of people miss that back term, and they don't put a 1 back there. So no, I wouldn't say you don't know what you're doing.
So I got to do a -1.
But when we say that, I need you to be a little more specific. When you say I got to do a -1.
I see a negative 4x plus 1. The only way I could make them match is multiply -1 on the outside, right?
Well, remember, in this situation, we would be looking at factoring. So you can factor out a -1 out of that bottom expression. And if you pull negative out of both terms here. Still have 25 on top, 4x minus 1. But then we'll have negative 5 because you put the negative out. If you take a negative out of 4x, negative 4x, you'll be left with 4x. Take a negative out of positive 1, you'll be left with negative 1.
So bring out a negative 1, that's negative 5. 4x minus 1. The 4x 1s cancel out. And 25 divided by negative 5 is 5. Negative 5. That's my answer.
Yep, negative 5.
See, I can't remember all the steps. I'm trying.
Right. Excuse me. Right.
Is there a simpler way to do this, or this is the only way you can do it?
Yeah, man, that's pretty much it. Let's do another one. All right, so let's go back.
So I have to multiply my LCD times every number that's in the numerator.
Mm-hmm.
And every number that's in the denominator.
When you say every number in the denominator, every numerator that's in your denominator. Are you saying that?
No, I just multiply by every numerator. Okay, every numerator. Okay.
Right. Every numerator. Uh-huh.
So this is another one. This is W1. Let me write it down. W over W plus 4 divided by W plus W over W plus 4. My LCD is W plus 4.
Yes.
W plus 4. W plus 4 times W. W plus 4 times W plus W. Can you hear me?
So you said W plus 4 times
W plus W.
when you say W plus. Now, so I want to make sure we're saying the same thing. So in the numerator, you're going to multiply the W times W plus 4.
Yes, sir.
All right. So now in the denominator, these are two separate terms. So that means you're going to multiply W times W plus 4. And then here, W times W plus 4. Is that what you're saying?
Hold on.
Mm-hmm.
Okay, hold on. W over W plus 4 plus W. Oh, I see it now. Okay. Now the top term would be, can you hear me?
Yep, I'm listening.
W to the second plus.
Oh, I'm going to go ahead and stop you because you're doing extra work.
Okay.
W plus 4 is canceled.
They cancel out?
Mm-hmm.
You're right. That only leaves me with W.
Yep. Remember, that's your whole purpose of multiplying each term by the LCD. So these things can cancel out for you.
At the bottom, the both W's plus 4 cancel out.
Yep.
That only leaves me with W plus W.
All right, so let me write this. W plus 4 is canceled. Leaving you a W here. And now this over here, let me go back to my red.
Oh, I got it. That's a separate problem. I got to multiply that one.
Right. Those don't cancel, so you have to go ahead and distribute that. So that'll be w squared plus 4w.
W squared plus 4w.
Mm-hmm.
I didn't see it. So I rewrite it on a free space. I factor out w squared plus 4w. I factor out the w. That leaves me with w plus 4 in parentheses. Wait, mine don't look like that.
Hold on now. So do you have this?
No.
So where did we go wrong? What did we do different?
The top part, hold on. To be honest, I don't know where I went wrong.
Now you did write the problem exactly the way I wrote it, right?
I wrote it when I wrote it W. I got to the canceling out part.
Mm-hmm.
I wrote it W plus 4 on parentheses on the numerator times W divided by W plus 4. On the bottom on the denominator, I got W plus 4 times W over W plus 4
Mm-hmm.
plus W times parentheses W plus 4.
Right.
Okay. When I saw the numerator, I got W.
Right.
When I go to the denominator,
Mm-hmm.
I'm left with W
Mm-hmm.
plus W to the second plus 4W. I see it now.
Okay.
I see it now.
All right.
W over, rewrite it as W to the second plus W plus 4W.
Mm-hmm. And those are like terms.
Yep.
So you can add those together.
Well, I can't add the W to the second. I can add the W and the 4W.
Right.
Right, so that's equals W. That's W to the second plus 5W. Factor a W. That's W plus 5. So my answer will be W in the numerator over W times W plus 5. Oh my God.
Now you're almost there though.
I got the
Say that part?
I got the factor part.
Right.
And W in parentheses, W plus 5. The W's cancel out.
Yep.
My answer is W plus 1. That's why I be messing up on the review. 1
Mm-hmm. Right.
over W plus 5.
Right.
I don't know if the class want to stay with me on this or they want to leave or what. It's gonna be a while for me.
I think everybody will be all right. We were about to, it's only a few minutes left in class anyway. But everybody's always free to leave if they want. Everybody's adults, they grown, so don't necessarily have to make the announcement, you know what I mean?
Yeah,
I think everybody, for those who stay in and benefiting from the conversation.
I just want to be considerate of others. That's all.
Yeah.
I don't want them to think I'm denominating all the time.
Right. But yep, if anybody have any questions, always, the floor is open. There was something else I was going to do anyway. But the floor is most definitely open if someone has a question other than Mr. Coley. So let's try this one.
That's a 9, right?
Yep, 9 over y.
9 over y plus 8 over y plus 1. 8y minus 9y plus 1. Oh, Lord Jesus. My LCD is y plus 1.
Close.
Y parentheses plus 1.
Mm-hmm.
LCD is y parentheses y plus 1. Now, my numerator, I will multiply each numerator by y parentheses y plus 1. Am I correct?
Yep.
So y parentheses y plus 1 times 9 over y plus y parentheses y plus 1 times 8 over y plus 1. Draw the line. Divide line.
Mm-hmm.
Y plus 1 times 8 over y minus y parentheses y plus 1 times 9 over y plus 1. The y's cancel. Now go back to the numerator. The y's cancel out.
Yep.
That leaves me a y plus 1. Not, rewrite on free space 9y plus 9.
Mm-hmm.
Second part, the y plus 1 cancels out. Plus 8y. Draw my line. The y's cancel out on the bottom. That leaves me a y plus 1. So that's 8y plus 8. The y plus 1's cancel out. That's negative y times 9. That's negative 9y. That means I got to factor my top part. Whew,
If possible.
if possible. If I
Mm-hmm.
use the AC method, it'd be 72.
So I don't think anything's going to be factorable after you combine your like terms. Yep, that's all you get right there.
Right, combine the y's, that's 17y plus 9, negative y plus 8.
Mm-hmm.
Oh, woo. We have time to do some more?
You got to get one more in before I got to go to this next class.
Okay.
So let's see.
Let me recite this back. I recite it back to try to get it in my brain.
Mm-hmm.
My LCD is multiplied by every number that's in the numerator.
LCD is multiplied by each number in the numerator. Yes, yes.
And I use my LCD to cancel out my denominators.
Mm-hmm.
I know I sound like a recording, but I be doing data dumps, and I get frustrated because I don't remember when I get to that section.
It's all good, sir.
You got me doing that. I'm doing it now.
Let's see, complex numbers. That's 4. Hold on. Okay, we're in chapter 3. Hold on. What? There we go. Complex fractions.
You ain't got nobody holding your hand on the test. You just got to figure it out. Lord Jesus. I call on the Lord so much. I would never thought math would make me call on the Lord. All my years on this earth, I never thought math would make me call on the Lord.
Ain't nothing wrong with that, sir. Be like that sometimes.
Oh my God. Oh, that's the other one. I'm glad you brought that up. Thank you.
Mm-hmm.
Thank you, Professor.
Not a problem. So here we have 2 to the x minus 1. 2 to the 2x to the negative first power. There you go. Then plus y to the negative first power over x to the negative second power minus 7y to the negative first power. So first thing we can do is recognize that as fractions, this is how this will look. Or in other words, rewriting our terms with positive exponents. So that's how we're looking.
So just go ahead and rewrite it.
Say it again.
So just go ahead and just rewrite it.
Yep.
Now I got a question for you.
Mm-hmm.
Wait, hold on. That x is really 1 over x. That exponent. I got it. I see it.
Yeah. Mm-hmm.
1 over x over y, 1 over y. And at the bottom is 1 over x to the second over y. Okay, cool. I see it.
All right. So now we need our LCD.
1 over x to the second minus 7y. LCD.
Mm-hmm.
I would go with x to the second. Ooh. Y. Why do I put the x to the second in parentheses?
No, that's not neat. That's not necessary.
So x to the second and y?
Yep.
Just write it like that? Okay.
Yep.
Then on the outside, take x to the second, y, in parentheses, times 2 over x, plus x to the second, y, times 1 over y. Draw a line, x to the second, y, times 1 over x to the second, minus x to the second, y, times 7y.
Mm-hmm.
You already went ahead.
Yep. I mean, you were writing it, so
All right.
I knew you were focused on what you were doing.
The x is 1x cancels out. That leaves x1.
Yep.
So that's 2x. That's 2xy. Y cancels out. That leaves x to the second plus x to the second. I go to the bottom. Both x to the seconds cancel out. That leaves with y. That's 1y minus, both y's cancel out, 7x to the second. I'm left with 2xy plus x to the second over 1y minus 7x to the second.
Mm-hmm.
All right.
Mm-hmm.
Now I saw that. Let's see, which one did you cancel out? You cancel out the x to the seconds and the top and bottom. You cancel out the y's. So that should only just leave me with 2x over 1 minus 7.
Now, no, remember you got to cancel out quantities. So you can't cancel out like that because of that plus and minus sign. So the most you could do here is pull out x. and see if that helps you.
In the top,
Yep, in the top.
let me rewrite this because the way I got it written as, let's see, 2xy plus x to the second over y minus 7x to the second. So in the top, pull out an x, that's 2y plus x.
Mm-hmm.
On the bottom, there's nothing I can pull out.
Mm-mm.
So y minus 7x to the second. So that's the answer in simplest form.
Yep, that's all you can do.
All right, Professor Tucker.
Sure it's gonna be all right, sir?
It is what it is. I'll take the test again. I'm going downstairs, take me a quick break, then
All
log
right.
back on and go to TCC's campus and try to take it again.
Gotcha. Hold on, let me see. Hold on, today is, what's today? Tuesday. All right. So, all right then. If you're good to go, sir, for right now, I guess. You know how to get in contact with me. Anybody else with any other questions before we look to close today? Everybody good? Everybody straight? So, all right. We have what, 3 more sections of new material to go. And then after that, we'll just be reviewing, just answering questions. So, yep. Don't forget to take those tests, schedule them through Mr. Davis so you can knock them out. And we'll go from there. Let me know if there's anything I can do to help you guys out. So until Tuesday, you guys have a great weekend and be safe.
Thank you, Mr. Tucker.
No problem, sir. Thank you.
Thank you, Professor Tucker. You do the same.
All right. Thank you, sir. Have a good one.